Pre-calculus scholars, we are starting our last major unit. We're going to touch on some other key topics in May that you need to have, but we are going to talk about logarithms and exponents. And hopefully today feels so easy because it is a review for what you've been covering. I had before in Algebra 2, but a lot of you didn't really even understand what logarithms were and their relationship with exponential functions. And I really just kind of want you to see if you guys can kind of bring some of the stuff together that we've been doing as well. Here's the things I want to give you for advice. Remember to wake up by 8 in the morning. Get your homework started right away at 9 o'clock. Try to be finished by 4 or 5 o'clock at night, and then have a life, okay? But you have to be really good. If you get behind for me, you need to understand if you don't turn your homework in on time, you are considered absent for my class. If you don't message me that you've submitted the homework assignment, I cannot grade it. So just kind of keep that in mind when you're doing this. So let's go ahead and let's do some review from the beginning of the semester, kind of like in February. And let's do some graphing real quick and talking about like our parent functions. So the first thing I want you to do is to graph your parent function. Y is equal to e to the x. And remember, we call this the exponential function. What were the key things you needed to remember to graph for the exponential function? Well, we had to graph where it was crossing the y-axis, and it crosses it as 0, 1. And remember that we comes up, and we would be exponentially growing really large. So that was our exponential function. Now guys, anything like that would work. You could go y equals 4 to the x or y equals 2 to the x. Those are all exponential type functions. And guess where they all cross at? 0, 1. So using that real quickly, then I want you to graph, pick a different color like blue, red, well, I'm not red, sorry, because I used red. Green, something like that. And I want you to graph your parent function, y equals the natural log of x. Now remember, natural log is just a logarithm with base e. What is e? E is a number like pi that has no end. It's irrational, and it goes 2.718, blah, 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 blah. But it is a key number that is used in, which was really kind of cool, in a lot of mathematical models, engineering, statistics, calculus, all the time. So it's huge. So just remember, you could rewrite that as y equals log base e of x. So we are talking about logarithms, okay? But where is the natural log? Well, the natural log we know crosses the x-axis at 1, 0 and looks something like this. Now, here was my question. Are these two functions inverses of each other? And the answer for that is absolutely yes. Now, why? Well, the reason why I know this is if I look at their graphs, they're reflecting over the line y equals x. So remember, it goes over our line parent function. Reflects over y equals x. So we know they are. Now, so what's another way of describing the relationships of inverse functions? Also remember the domain and range switch for the functions. Now some of you are like, oh crud, she used the words domain and range. Remember, domain is your x coordinates and range is your y coordinates, okay? So remember, that is where it switches. All right, so now we're going to talk about a logarithm. Now, this is going to be the formal definition. You probably would have saw this in your Algebra 2 notes last year. But remember, everything is based off of these. So this very first equation right here says y equals b to the x. That is an exponential function, an exponential equation. A logarithmic function is its inverse equation that is written like the following. Is log. Now, we can use natural log if we're working with natural log stuff, so understand. base b, so it's a subscript, which means it goes down, of y is equal to x. Now, I want you to notice some things. Look where y is located. Different things. Look what your base value is. Your base value is what's being raised. Oops, you know what? That doesn't work really well. Let's change that to black, okay? So it would be there. And then last but not least, my friends, look where your exponent lands. It's equal to your exponent. So when we read this, here's how you have to read the following, okay? That is log base b of y is equal to x. So it's equal to the exponent. So really, when you talk about logarithms, we're working with the exponential rules, and we will talk about that in the future days with these lessons. But guys, you have to be able to convert between these two forms, and that's just really what I'm asking you to do today. First of all, to realize that exponential functions and logarithmic functions are inverses of each other, okay? And that you need to be able to switch between the two. Why is it important that you're able to switch between these? Why are we even caring about logarithms? Mrs. Gregerson, I'm not going to do anything. Here's the deal. It's on your college entrance exams. You have to know how to do this. And if you know how to convert to exponents, you can change things to logarithm as if it's easier to solve. If something's a log, you can change it to exponential form and solve it that way. It's a time saver and it's an actual problem solving skills. So we need to be able to switch between the two. So the very first thing we're going to do is we're going to write each logarithmic equation. We're going to rewrite it to an exponential form. So remember, what is the base with this one? If we're doing this, the logarithmic form, if you remember, the base is what's being raised. So 4 is my base right here. All right, does not want to write for me right now. Not sure what I did, but here we go. Come back. All right, so that's our base. So we're going to be 4 is being raised, okay, to 3 equals, and this is your answer, what's equal to 64. So 4 cubed, and guys, think about that, is 4 cubed equal to 64? Yes. So that is the exponential form of that original logarithmic equation. So let's look at the next one. We have log base 3 of 81 is equal to 4. So what's the base of this? It's 3. It is being raised by my exponent, so it's 3 to the 4 equals 81. Well, guys, what's 3 to the 4th? That's right, 81. All right, so now let's look at the next one. Again, what is our base? You have to pick that out first. The base is 7. So we got 7 raised to the exponent, which is -2. Remember, this is your exponent. This is your base. And really, that comes out your answer is equal to 1 over 49. Now, remember, negative exponents means you move locations in a fraction. So that would really be 1 over 7 squared. Well, 7 squared is 49, so it would be 1 over 49. Okay, now what happens if there is no base? Like it looks right here, Mrs. Gregerson, there is no subscript. B is missing. It's like, oh. Here's the deal. It's not missing. If there is not a base there, it's understood to be 10. So if no base written, with log, the base equals 10. So in this case, my friends, this is really, you could put a 10 there. And it's really 10 to the -3 equals 1 over 1,000. Now, let's do a subscript sidebar here. Let's go off to the side here. If you ever see something like this, natural log of x is equal to, let's just say 3. Really, when you see natural log, that's really log base e of x is equal to 3. We just write it. It's a very fancy notation. And we actually use natural log more than log in the long run. And so really, if I was to ask you to switch forms, that would be e to the third is equal to x. So if you ever see natural log, this is what that means, log base e. But we just don't sit there and rewrite it as log base e. We just understood that's the case. All right, so let's write the last 4 down very quickly. We take our base, which is 32. We raise it to our exponential power, which is 2/5, and that is going to equal 4. Not sure what's happening again, but hey, we're going to go equals 4. Okay, doing the same thing with f. What is going to be our exponential form? Well, that is going to be our base raised to my exponent, so 16 to the 3/4 is equal to 8. Now, remember how you would actually calculate this. Remember, fractional exponents mean radicals. So that'd be 16, the 4th root of 16, which is 2. 2 being cubed then gives us 8. So we can double check if this makes sense. All right, and then we get our last one. What's our base? Our base is 2. So it's 2 raised to the 1/2. It's the same thing as the square root of 2. Exactly, right on. All right, let's get our last one. I would be 5 raised to the 2/3 is equal to the cubic root of 25. So our base, our base being raised to our exponent equals the cubic root of 25. All right, now we have to be able to go the opposite way as well. If I give you exponential form, you need to write it in logarithmic form. And again, look back at the top of the notes here and it will help you go between the two. But here's the thing you really need to do. Make sure you know what your base is, okay? So this is going to be our base. So this is going to be log base 3 of 729 is equal to 6. So really, here's what we're doing is like, what do I have to raise 3 by to equal 729? Oh, 6 is kind of what that's saying. What do I have to raise 3 by to get 729? Oh, that equals 6. Now, let's do the next one. What's our base? Here's our base. Here's our exponent. So we rewrite it as the following. Log base 2 of 32 is equal to 5. All right, let's keep doing these real quick. 81 to the 1/4 is equal to 3. What's our base? Our base is 81. So log of 81 of 3, of 3, equals 1/4. Boy, I totally second-guessed myself on that one. I should have known better. So sorry, friends. All right, let's look at the next one. We have 10 to the -3 equals 0.001. Now remember, this is my base. This is my exponent, and yes, you can have a negative exponent in this case. So we go here, log base 10 of 0.001 is equal to -3. Or you could write it without the 10 in the exponent. It does not want me to do this. I'm not sure what I clicked when I did that. Or you could go log base 0.001 equals -3. You could have the 0 in front of the decimal or not. It's kind of up to you. All right, now you can do this all with variables as well. So here we have n raised to the a is equal to 4. But here's the thing you need to remember. This is my base. This is my exponent. All right. So when we work with it, we go log base n of 4 is equal to a, which is your exponent. All right, let's get our last one down. Guys, what's the base for this one? M. Okay, what's the exponent? T. So we're going to go log base m of 10 is equal to t. Now, today's homework, you have 16 problems. Just make sure you read things carefully of just converting the different forms. Please get really, really good at this because we're going to be applying it later. Guys, have a great weekend. Stay out of trouble, my friends, and Just pray that you and your family are doing well.